Like I was saying, today we're going to look specifically at fractional exponents and how to convert them to a radical, and vice versa, how to go from a radical and write it as an exponent so that we can use our exponent laws. So when we have something like this, x to the 2/3, to write it as a radical, the denominator of your fraction, that becomes your index. So do you guys remember where the index goes in the radical? It goes in that little crook. So that 3 is going to come out here, and then inside you'll just have x squared. And that's how you can convert a fractional exponent into a radical. And it can go the other way. If you had it in this form, you take whatever the index is, bring it to the denominator of your fraction. And that's how you can convert back and forth. So we're going to just practice today mostly with converting and then simplifying if we can. So if we look at number 1, we're going to start by converting it to a radical. So that 3 is going to come into the index, and we'll have 8 squared. Well, what is 8 squared? 64. And then to evaluate would be to see if can you reduce the radical. So when we break down 64, we'll have 8 times 8, 4 times 2, 4 times 2, 2 and 2, 2 and 2. So we end up with 2 groups of 3 2's. So that means the cubed root of 64 is going to be 2 times 2, which your answer is 4. We can usually only do this evaluation if it's a number. If we have letters, can't really evaluate anything. But we do have to go simplify it if it is in fact numbers. What's wrong, Chase?
What confuses me is, like, I know this is the way you're supposed to do it and all, but 2/3 of 8 isn't it 4.5?
Okay, it's not 2/3 of 8, it's 8 to the 2/3 power. So we're not multiplying 8 times 2/3. Okay, so let's look at the next one. A to the 1/5. The 5 will come out as our index, and we have a to the 1st on the inside. Can we simplify that? No, it's a letter, so then we would be done at this point. So then when we look at something like number 3, 12a to the 2/3. This is where it's important to remember that where is the exponent? Is it on the 12, the a, or both? Just the a. So when we go to write it as a radical, it only goes over the a because that's what it was on. So when we write this, the 3 does become our index, but only to the a squared. The 12 was not a part of it, so it has to stay outside. And again, we can't evaluate that any further because we have a variable. Now on number 4, because it's in parentheses, does that 4/5 go to both of them or just one of them? It goes to both. So this 5 here will go into the index, and inside we'll have 64a to the 4th. Okay, so then from here, this number is going to get really big, and I didn't leave enough space to do it. But we would find out what is 64 to the 4th, and then try to break it down to see if we can simplify. On number 5, 25x to the 1/2, again, because it's in parentheses, all of it's going to go inside of our square root, because all of this has the exponent. Can we simplify this one? Yeah, because we can break apart 25, and we have a pair of 5s. The x was just an x, there was no pair, so it's left over, and we have 5 square root x.
So why doesn't the 2 go?
Yeah.
Why isn't the 2 in x?
Okay, because remember, what is this default to when we don't write it? So remember when we were talking about square roots on Tuesday, if it doesn't have the 2, anything written, it's by default a 2. If you want to write it, go ahead. It's just not necessary because there's no such thing as a first root. The starting is second root or a square root. So when you don't write anything, it's assumed to be a square root. So that's why if you want to write it, you can, but you technically don't have to. Okay, right here we have kind of, so when I was doing all of these up here, I was always putting my numerator inside my radical, but there is a way that you can also write it outside the radical. So if I wanted to, say on number 4, to not have such a big number, we can also have written this with the 4th power outside the whole radical. These are the same statement. Now, is something like trying to simplify the 5th root of 64 a little bit nicer to do? Yeah, because if we break down 64, see, we did it up here. We had 1, 2, 3, 4, 5, 6 2s. So 1, 2, 3, 4, 5, 6. Do I have a group of 5? Yeah, we have 5 2s. So then we can say that it's 2 5th root 2a all to the 4th power. So it helps us keep numbers smaller and easier to reduce if we sometimes put that exponent outside rather than inside. But you can write it either way. So sometimes we want it inside, sometimes we want it outside because it helps make things simpler. Okay, so we're going to go through, I think I have 11 total examples, where we're going to now switch to going from radical form into exponent. So are there any more questions about how to convert from a fractional exponent to a radical? Because now we're going to flip it and go the other way. Ryan.
For number 4, could you just put the parentheses over the 2a instead of like the whole thing, or would that be different?
It has to be over the whole thing. Because this 2 5th root 2a, that was all of this inside parentheses simplified, and so we got to keep it in parentheses. Now if you wanted to, you could actually figure out what is 2 to the 4th, and then you would only put the radical, but until you raise it to that power, it has to stay there.
When you do the simplification, do you do the exponent first and then?
Depends on where you put it. So, like on number 1, I had my exponent inside.
Yeah.
So then I did my exponent and then simplified. But here, doing my exponent first was gonna give me a huge number. So that's where I put it outside so I can simplify inside and then do the exponent. So that's where you want to kind of try both ways. They'll give you the same answer. It's just which one's going to get you there a little bit easier. Because remember, all you have is that baby calculator. So you probably don't want to deal with a lot of large numbers. Okay, any other questions before we move on to converting radicals to exponents? Okay. So converting radicals to exponents, we're going to be taking the index and bringing it around to be the denominator of our fraction. So this is going to equal x to the 3 over 5. When you do this, if you can reduce the fraction after you put the index in, reduce the fraction. Okay. So on number 6, what would that look like when we write it as an exponent? The 5 will come into our denominator, so b to the 3 over 5. Because it's a letter, we can't really do much more with it. So that would be our answer. When we look at number 7, we have to think of this 27d to the 5th. All of it's in the radical with a 1 outside. So when we go to put this 3 into the denominator, it has to go to the denominator of 1. Because all of that, it's kind of going, it's like going backwards from this one here, how that 4 was outside of everything. When we go this way, we have to think of it as a 1 out here, so that that 1/3, or that cubed root, is going to everything in that radical.
Like, so when do you know to put it in parentheses?
Whenever usually it's whenever you have more than one thing. Because see how here we just had a b, but here we have 27 times d to the 5th. So it's whenever you have more than one thing in the radical, put it in parentheses with a 1 outside, because then from here we can use our exponent rules. We can do 27 to the 1/3, and then d to the 5/3 when we do power to power. And this right here is where going back and forth is going to be helpful. Well, actually, let's just stop there on that one. Okay, so this would be the exponential form for that one. We haven't simplified it, but it's just converting it to exponential. I'll go over how to simplify it here in a minute. So then on number 8, the radical's only over the x. So we don't have to do the parentheses with a 1, because we only have the one thing. We'll have the 12x. The 3 will come to be the denominator of 4. And that would be your solution. Okay, how are we doing on the converting part? Okay, so the last 3 we're going to evaluate, which means if we can simplify it, we're going to simplify it also. And sometimes when we simplify, we're going to go back and forth between radical and exponential to help us get that done. So with number 9, we're going to start by writing it in exponential form. So what do we do when there's already something in the denominator? Because where does the 5 have to go? It also has to go down there. So when you already have a denominator, you're just going to take the index and multiply it to whatever's already down there. So this is going to become x to the 1 over 20. And again, because it's a variable, we can't really go any further. So we would say we're done. On number 10, though, we can rewrite it as the 6th root, so the 6 comes out as the index, of 64. Now, do we want that 5th power inside or outside? We want to put the 5 in here with the 64 or outside parentheses around the whole thing. Anyone have a preference? Okay, outside. Can I ask why you chose outside?
Because it's a big number.
Because 64 to the 5th is a really big number. Okay, so let's try simplifying square root 64. Well, see, we did it up there earlier. 8 and 8, 4 and 2, 4 and 2, 2 and 2, 2 and 2. So we're looking for a group of 6. So I have 1, 2, 3, 4, 5, 6 2s. So that means I have 2 to the 5th power. Because all of this in here became just 2 when we simplified the 6th root of 64. So what is then 2 to the 5th? 32.
Wait, so when you do that, the number on the 6 disappears, it's just like the final number.
Because we were able, when we didn't have any leftovers, so when we simplified this, we did not have any leftover numbers, which means it was a perfect 6th root. So yeah, we don't have that 6 anymore. If we had something left over, then we would put it the 6th root of whatever is left over. Okay, number 11. You'll sometimes get problems that have exponents and radicals mixed together. When you have this, convert everything into exponential form, because we have all these properties that help us combine exponents of like bases. So go ahead and convert everything to exponential so you can combine what you can. So I'm going to start by taking this one here and writing it as 3 to the 2/3. And then what can we do to combine those bases? What do we do the exponents? We add them. So 2/9 plus 2/3. So again, if you need to come over to the side to do your fractions, 2/9 plus 2/3. Multiply top and bottom here by 3, and we get 6/9. So 2 plus 6 would give us 3 to the 8/9. And that would be your exponential answer. Now this is also where you want to be careful that you read your directions, because sometimes the directions will say leave your answer as a radical. So how do we go back and turn this into a radical from here? The 9th root of 3 to the 8th. And that would be your radical form. So depending on the directions, you'll leave it in either exponential form or radical form.